You might think that Mercury, being the closest planet to the Sun, would naturally be the hottest in our solar system. However, the reality is quite different and surprisingly intriguing. Venus, the second planet from the Sun, claims the title of the hottest planet. Venus's atmosphere is the key to its scorching heat. Unlike Mercury, which has a very thin atmosphere, Venus is enveloped in a thick layer of carbon dioxide with clouds of sulfuric acid, creating a runaway greenhouse effect. This dense atmosphere traps heat incredibly efficiently, preventing it from escaping back into space. Imagine a planet-sized pressure cooker, and you have Venus. The surface temperature on Venus can soar to a blistering 465 degrees Celsius, hot enough to melt lead. But there is more to Venus than just its heat. The planet rotates on its axis in a direction opposite to most planets in our solar system, including Earth. This retrograde rotation means that on Venus, the Sun rises in the west and sets in the east. A day on Venus, from one sunrise to the next, lasts longer than its year, taking 243 Earth days to complete one rotation, while it orbits the Sun in about 225 Earth days. This slow rotation contributes to the extreme conditions on the planet. Venus's atmosphere is also incredibly dense, with a pressure 92 times that of Earth's at sea level. This immense pressure, combined with the high temperatures, makes the surface of Venus an extremely hostile environment. Spacecraft that have landed on Venus, like the Soviet Venera probes, survived only a few hours before succumbing to the harsh conditions. Recent studies have revealed fascinating insights about Venus. Scientists have discovered that Venus might have once had oceans and a climate similar to Earth's. However, a catastrophic greenhouse effect took hold, evaporating any water and turning Venus into the fiery world we see today. These findings have sparked interest in understanding Venus's past and what it can teach us about climate change and atmospheric dynamics. Moreover, the clouds of Venus are not just ordinary clouds. They contain sulfuric acid, making them highly reflective and contributing to Venus's bright appearance in our sky. Venus is often called the evening star or the morning star because it is the third brightest object in the sky after the Sun and Moon. In recent developments, scientists have been exploring the possibility of microbial life in the Venusian clouds. In 2020, a team of researchers detected phosphine, a potential biosignature gas, in the atmosphere of Venus. This discovery has led to renewed interest in the search for life beyond Earth, with planned missions aiming to explore Venus's atmosphere in more detail. So why is Venus hotter than Mercury? It all boils down to its thick, heat-trapping atmosphere. Venus's atmosphere acts like a thermal blanket, preventing heat from escaping and creating the hottest surface temperatures in the solar system. Despite its proximity to the Sun, Mercury lacks such an atmosphere and cannot trap heat as effectively as Venus. In conclusion, Venus is a planet of extremes, with its intense heat, crushing pressure, and intriguing atmospheric dynamics. As we continue to explore and study Venus, we gain valuable insights into planetary science, climate, and the potential for life in the most unexpected places.